Thanks. It's always good to get the applause before the talk, isn't it? I mean, that's much easier. And I figure I've got 1 minute now to give this talk, so I'll try my best, given I'm meant to be finished at 2:35. As anyone knows, air pollution in Singapore is a major challenge. And it's been covered a lot by the media. I'll skip the video here for brevity. But there are major haze events in Singapore that have really brought air pollution issues to the fore of the public mindset here. Now, there's really a couple of ways to divide this out. One is that there are short-term haze events, and these are related to acute health impacts. And there are also long-term average exposure that's related to chronic health impacts. Now, this latter piece, the long-term average, is what dominates health costs by some 80 or 90%. So while the short-term events dominate the headlines, the long-term average air pollution that Singaporean residents and citizens are exposed to are what dominates health impacts by almost order of magnitude more than the short-term stuff you see in the headlines. Now, the second question then is, which pollutants affect health the most? And the answer, as epidemiologists tell us, is that it's fine particles, particulate matter with a diameter less than 2.5 microns being the metric that's typically used, and that's denoted PM2.5. So I'm going to focus on then PM2.5 in Singapore and long-term averages being what dominates health impacts. So the motivation for this then is to try and inform policies that the government of Singapore might make. The government set very ambitious targets for improving particulate matter PM air quality in Singapore. And those policies will be better informed if we can disaggregate the causes of PM air quality degradation in Singapore, including what comes from stuff happening within Singapore so the government can very directly influence, and what happens from activities outside Singapore, transboundary effects. So I'm going to talk about our modeling methods first, then biomass burning, and then apportioning the impacts of PM on Singapore, and finally some concluding remarks. Now, if you're looking at something very local, like you're near a power station and you want to know how much of the pollution you're exposed to from the power station, you can just measure it, look at the wind direction, and infer pretty directly the impact on air quality. But if you're looking over scales of tens, hundreds, and even thousands of kilometers, all of which affect Singapore, then these kind of relatively simple, localized, empirical approaches don't work, because all the stuff that gets emitted into the atmosphere interacts and reacts chemically, and it's all nonlinear, so that doesn't really work. So in order to figure out what affects air quality in Singapore, we need a modeling approach, which means we capture the physics and chemistry of what's going on in the atmosphere. The approach we've chosen to take is based on something called CMAQ, which is a modeling approach developed by the US EPA to support the Clean Air Act, which was sort of some of the pioneering legislation globally that's saved hundreds of thousands of lives so far in the US. And it takes emissions, and we've developed emissions inventories for industrial, residential, power and transport in Singapore and the region, biomass burning based on satellite measurements of hotspots, so infrared measurements, and then inferring from that emissions and plume rise, and also shipping emissions. And so all these emissions get put into the air quality model, and then the model also takes in weather forecasts, actually hindcasts of what the weather was like, meaning wind direction, temperatures, and other meteorological variables. And finally, we use that to estimate the contribution of these different 6 cases listed in the bottom right here. So biomass burning, fires, Malaysia, Indonesia, shipping, and domestic Singaporean emissions. Now, I mentioned that really the whole world affects air quality in Singapore, but Singapore is a relatively small place, so that means we need to nest down from a global scale right down to something around Singapore, and then continue to nest down to Singapore to capture the impact of very large-scale things right down to a Singaporean scale. And so we go from domains with a scale of some 10,000 kilometers globally to some 50 or 100 kilometers locally. Now, this modeling gives rise to the chart on the left here, which is the annual average PM2.5 concentration in Singapore, peaks up to 40% near Malaysia. And we find that while we don't have monitoring stations we can directly compare against due to local issues in comparing them, we do know from measurements we made and been given by NEA that the models are roughly within 30% of what's actually measured in the real world. So let's now move on to the results of some of this modeling. At first, PM2.5. Now this movie here shows the results of the simulations, and it gives you a sense of how these models work. So they take all the emissions estimates, the emissions dispersed in the atmosphere, chemically react, resulting in PM2.5 from biomass as shown here. And you can see the pollution spreads out, disperses, and ultimately gets removed mainly by rainfall, which scavenges the particles out of the atmosphere. Now these, you can see here, biomass plumes emanating particularly from Sumatra and parts of Malaysia. And as we move towards September, you'll keep an eye out on Singapore in the middle of September, where you'll see very big peaks in concentrations that occur, which those of you who are here in September 2009 remember caused some disruption in Singapore. So right about now, you'll see those plumes occurring. So this all does suggest we can capture what happens in the real world with these kinds of models. Now, going back to the annual average, the total is shown in the top here, and you can see here the concentrations. And while the haze events I mentioned give you the big headlines, that global headlines, the biomass burning actually is pretty small when it comes to the annual average. You can see in the bottom left here some 6 or 7 micrograms per meter cubed annual average compared to some 20 or 30 around Singapore. So not actually as significant as you might think in terms of annual average impacts. And remember, it's those annual averages that matter most for health. Then if you go to the bottom right, that shows the impact from within Singapore, so domestic emissions and the contribution of that to air quality in Singapore. So what if we apportion this then by exposure in Singapore? Domestic here is some 54%. So just over half of the PM2.5 exposure in Singapore is caused by emissions within Singapore, and therefore is most directly controllable by actions that are taken within Singapore. About 9% is due to biomass burning and 37% the others. If we then look at spatially where those transboundary sources impact Singapore, as I mentioned, 54% within Singapore, 46% outside of Singapore, of which the biggest single contributor is Malaysia at some 27% of the health impacts in Singapore are caused by emissions from Malaysia, followed by Indonesia at some 14%. So this tells us that roughly half of the air pollution challenge in Singapore can be tackled by measures taken in Singapore, and just under half requires working with neighboring countries to address the issues. So to conclude then, I'm sorry I've overrun by almost the entire length of my presentation compared to the time I was aiming for. We've assessed the influence of domestic and regional sources on air quality in Singapore. And while biomass burning really gets the headlines, it accounts for about 9% of total annual average exposure to PM in Singapore. And so you'd infer from that about 9% of total health impacts comes from biomass burning. So 54% is from the stuff within Singapore, and the remaining parts from Malaysia and Indonesia. We also have developed a modeling platform to estimate air quality impacts in Singapore, and we're now working to use that platform to assess policies and measures that could be taken in Singapore and in the region to improve the quality of air in Singapore. So I'd like to finish by acknowledging collaborators, Dr. Akshay Ashok, who recently was awarded his PhD at MIT, who conducted most of this work. Collaborators, Professor Rex Britter, Les Northwood, and Steve Yim, and also the funding from NRF and our collaborators at NEA, who have helped a great deal with this. So thank you very much.
Yes. Is it possible for you to validate your simulation by the satellite estimate, like from the GMS or that MODIS estimates of the distribution PM2.5 in this region?
Yeah, so we're currently working on validation, and I just show you the sort of in situ measurements on the ground, but as you suggest, satellite-based observations will be somewhat helpful, but really we'll have to put together a set of different pieces of evidence that will add confidence to the results.
Thank you.
Thanks.